In this question, part 1 is find the largest number that divides exactly into m and n. Means divides exactly into means HCF, highest common factor, largest, highest, and both common, and divides means the factor. M here is 2 raised to power 2 multiplied by 3 times 5 square. M is a number, even n is an m, and both numbers they are given in terms of prime factorization. M is 2, 3 times 3 square times 7. If the numbers are given in this format, means as a product of their prime numbers, and the prime numbers they are written in power form as 2 raised to power 2 times 3 times 5 square, then 2 cube times 3 square and times 7. To find HCF of the numbers given in this format, we take the common numbers. As you can see here, 2 is there. From the common, we take the lower power. Means we have 2 common in both m and n. In m, 2 has power 2, where in n, 2 is raised to power 3. So the smaller one is taken. So 2 square will be here, and then another number, common number is 3. From this 3, only 3 or 3 raised to power 1 is the lower power, so that will be taken. Now 5 square and 7, they are not common. Take the common one, the number, the base which is common, and then from the common basis we take smaller power. 2 square is 4 times 3, 12. So this is the first part. Second part is if you need to find, I'm just telling you the concept of LCM. For LCM, in case of common numbers, you take the higher power or highest power, and the numbers, those are not common, they come as it is. If you need to find the LCM, I just give an example. If we were asked to find LCM, the statement for the question would be like, find the smallest possible number or the least possible number which is divisible by both m and n. So LCM, common multiple, common least common multiple. For that case, for m and m and n, the least common 2 is common. 2 is common in both, so we will take 2, 3. The largest power is taken. 3 is common, 3 square, the larger power will come, and then the remaining as it is. This would be, means if the numbers are common, their higher power will be taken, and if they are not common, they will be taken as it is. Now find the smallest value of k such that m times k. M is 2 raised to power 2 into 3 into 5 square times k, means we have to multiply this m by a number, and we have to keep k smallest possible, having smallest possible value, such that m times k is the cube number. Cube numbers are the numbers which have the powers divisible by 3. Means if the power is 3 or multiple of 3, means if it comes in the table of 3, then it is a perfect cube. Why its cube root is possible? Because cube root written in the form of power, that is 1 over 3. So if we will take the power of 3, power of power, they are multiplied. 1 over 3 when multiplied to the power, that power should be perfectly divisible by 3. In other words, if we need to have them as a perfect cube, all bases must have either the power 3 or a power which is multiple of 3, means which comes in the table of 3. So it means here if we need one more 2. So if there is multiplied by 2, it will become 2 cube. And in the here 3 is there, so we need, means 1 is there, we need 2 more. 1 already here, we need, there is 1 already. So this 2 more 3's are needed, and in case of 5, only 1 5 is needed. It means k, the smallest possible value of k should be 1 2 3 square and 5. Is 1 5 is required to make, if we multiply this expression by 5, 5 cube will be there. If we multiply by 3 square, 3 will have the power 3. And same is the case for 2. If another 2 is multiplied here, then we will have 2 cube. So it means 2 times 3 square times 5 is the smallest possible number which should be k, and that is 5 2s are 10. 10 times 3 square is 9, means 90 is the smallest possible number, smallest possible value of k, which when multiplied to m will make m a perfect cube, or we can call this is would be a cube number. Write down an estimate for 28. This is 28 over pi. Estimate means you don't need to give the exact value. We know 28 over, this is approximately 3.142 to approximately 3 in the denominator, and this is 28. So if there is square root, we need to have some appropriate settings. That is 27 over 3. That would be proper thing which we should take. There is approximation because you have to do it mentally. So 28 approximately means, or you can see 3 times 9 is 27. That will give us 9, and square root of 9 is 3. Approximately 3 will be the estimate of this. So 28, the closer friendly number can be 30, but in this case, the square root is there. To cater the square root, we would like to have a perfect square. So the perfect square can be obtained by 27 over 3, because approximately pi is equal to 3, 3.142. So approximately it is 3, and if we take 28, approximately 27 is about 27, or even if you can multiply 28 by 3, it will be 9 point something. So approximately the answer will be estimation. The answer will be 3. Then the next part of the question is express 60 as a product of prime numbers. Yeah, you haven't written here, so we need to have this one. 60 written as a prime number will be 3 times 20, 3 times 2 times 2 times 5. So it is 2 square into 3 into 5. 2 2s are 4, 3s are 12, 5 are 60. Okay. So 60 is, find the smallest possible integer m such that 60m is a square number. 60m is a square number. For square number, the power either should be 2 or an even number, means multiple of 2, should be divisible by 2. Why? Because if we take square root, the square root is as a power 1 over 2. So whatever we have within the bracket or whose square root we are going to take, that should be divisible by 2. Means if there is 3 square, I can simply say 2 times 1 over 2 is equal to 3. So it will be cancelled. If I have 3 3, it is not a perfect square. Why? Because the power will become 3 over 2, which is not a whole number. So if I have 3 4, it is a perfect square, because 3 4 times 1 over 2 is 3 square, which is 9. So if we need a perfect square whose square root is possible, should have a power 2 or multiple of 2. It means to keep this number a perfect square, this is okay. 3 square already is a perfect square, because we have to keep the m, the number which we will multiply to, which we multiply to 60. That should be the smallest possible. We have to keep it smallest. Otherwise, we can say m is 60. If we have m60, 60 times 60 is a perfect square. So we have to keep m the smallest possible. For that purpose, the part which are present here, those will be used. So in other words, we only need 1 3, that will make 3 square, and 1 5. So 15 is the value, smallest possible integer value of m, which will make 60 when multiplied with 15, that will make it a perfect square, or you can say is a square number. The lowest number, that is multiple of both lowest number, multiple of both 60 and an integer n, means there is an integer, there is 60 and another integer n. 60, as we have written, 2 square into 3 into 5, and n we have to find. And this lowest number, that is a multiple of both means common, lowest means least or smallest, multiple, this is LCM, means LCM of LCM of 60 and n. LCM of 60 and n is 180. 180 written as the product of prime factors, it would be 20 times 9. You can split it and you can write it. The 9 LCM is 180. So 180 is basically 2 square times 3 square times 5. Because 2 times 2, 2 square is 4, 4 times 5 is 20, 20 times 3 square 9, 9, 20 times 180, yes. So means this is the LCM, and we have to find the smallest possible value of n. What would be n here? If you recall, in the previous case, I have told you here, I will explain you how to find LCM. If the numbers are written as the product of prime factors as a power form, means prime factorization, but in power form. For the common numbers, we take the higher power. If they are common, if there are numbers common, we take their higher power or highest power. But if a number is not common, then we take that number as it is, even if it is present in any one of, you see here, we have taken 7, which is only in n, and we have taken 5 square, which is only in m. So the numbers which are not common, they are taken as it is, and the numbers which are common, we take their highest power. Now here what we can see here, 2 square. So we can say 2 square has come from 60. Even if we don't take 2 in n, it will make no difference for the LCM, because if 2 is not common, then that 2 square can be taken from 60. And we have to, as the statement of question says, we have to keep the n smallest possible. So there is no need to take 2. Why? Because if we don't take 2, it makes no difference, because if 2 is not common, the 2 square would have been taken from the 60. And same is the case for 5. If we don't take 5 as the value of n, makes no difference. Why? Because 5 can be taken from 60. If there is no common, no 5 in n, means 5 is not common, even then the 5 can be taken from 60. But in case of 3, in the answer we can see there is 3 square which is not present in 60. It means there should be 3 square in n. Why? Because we take the higher power or the highest power from the common. So there should be 3 square in many one of the two numbers, means either it should be in 60 or it should be in n or in both. So it means without taking 3 square, the LCM cannot be 180. We need 3 square in LCM. That's why 3 square can be taken as the smallest possible value of n.